Let us solve this problem. A wave is represented by the equation y is equals to 2 sine pi, open bracket, 0.5x minus 200t, close bracket, where all distance are measures in meters and time in seconds. For the wave, calculate its frequency, wavelength, and speed. Now, the only thing you need to solve this problem is you knowing the general equation of progressive wave. So, once you know the general equation of progressive wave, then all you just need to do is to compare. Now, we are going to do something now. We're going to bring out this equation that is being given to us in the question, and we're going to write it down. Y is equals to 2 sine pi, open bracket, 0.5x minus 200 what, t, close bracket. Now, the next thing I'm going to do is that I'm going to use this pi to open this bracket. So I have something like this. Y is equals to 2 sine, open bracket, 0.5 pi x. I'm using this pi to open the bracket. So minus 200, this pi t, close bracket. So once you have done that, then you have to know the general equation offhand. And that is what I want to write right now. So the general equation of progressive wave is y is equals to a sine, open bracket, 2 pi x over lambda minus angular velocity t. Now, if you look at what we have here, this equation actually resembles what we have in this equation, right? So here we are asked to find the frequency, but you see that this general equation here has nothing like frequency, right? So you can decide to further break down the general equation. So this general equation, I'm going to further do something like this. Y is equals to a sine, open bracket, 2 pi x over lambda minus this angular velocity. Remember that angular velocity omega is 2 pi what? 2 pi f, right? So what I'm going to do now is to change this to this. So here we have 2 pi f, then you have your t, right? Remember, all I said is know this. So you can always change, like angular velocity, you can change it to this anyhow. So once you do that, then you cannot compare it here. The question says we should find the frequency. So this is the question given to us in the question. This, can you see this A? So here, this A means the amplitude. So from here, the question asks us for the amplitude. Our amplitude is 2. You can see we have sine here, we have sine here, right? So the question asks for the frequency. The side that has the frequency is this side. And here too, the side should be this side. Am I right? So what we are going to say is that 2 pi ft here should be equals to 200 pi t, because this side must be equals to this side. That is exactly what we are trying to say. So I'm going to say, from the general equation now, 2 pi ft must be equals to this what? 200 pi what? Pi t. So from there, remember, I'm looking for my what? Frequency. So what is disturbing my frequency is 2 pi t. So I'm going to divide both sides by 2 pi t. So that's 2 pi t divided by 2 pi t. So here, this cancel this. So my frequency is going to be what? Pi cancel pi, t cancel t. 2 here 1, 2 in 200 is going to be what? 100. So don't forget this is 100 watts. And the unit of frequency is what? Is hertz. So my frequency is 100 watts. My frequency is 100 hertz, right? So the next thing that the question asks us to find is the wavelength. The question asks us to find the wavelength. Now, remember, if you look at the general equation again, you see the side that we have wavelength. Can you see the wavelength this side? And here, so this, can you see this x? Can you see this x? So it means that this side must be equal to this side. So because we can get our wavelength from this side, so I can say this 2 pi x over lambda here, to get my wavelength, 2 pi x over lambda is equals to what? Should be equals to this side. That's 0.5 pi x. 0.5 pi x. So remember, this x will cancel x, right? The pi will cancel what? Pi, right? So all I have left is 2 over lambda is equals to 0.5. Of course, this 0.5, I can change it to 5 over 10, right? So that's going to be what? 5 over 10. So here, I can cross multiply. That is going to be 2 times 10, that's 20, is equals to, this pi times 5 is what? 5. Lambda times 5 is 5 lambda. So I'll divide both by 5 here. My lambda, which is wavelength, is going to be what? 5 here 1, 5 here what? 4. So that is 4 what? 4 meter. So my wavelength is 4 meter from there. So once we are done with that, then the question asks finally for speed. Of course, you yourself should know the formula for speed of a wave. And what is the formula for speed of a wave, which is V, is what? The speed is equals to what? Frequency times what? Times wavelength. Frequency times wavelength. And that is why you must get your frequency and your wavelength. You must get them right. Otherwise, you will fail this last question. So here, this is going to be frequency, which is 100, times the wavelength, which is 4. So what is going to be? We're going to have 400 what? 400 meter per second. And that is going to be our speed of the wave. So you can see that this is very simple. So just find the general equation and compare it with the equation. Remember, know how to compare, do the comparison, and that is that. Thank you.